systems of linear equations means we're going to be putting more than one line on a graph, okay? And sometimes we'll see where they intersect or if they intersect. So here's a sample problem that you'll be dealing with. Two sisters want to know if they will ever have the same amount of money saved. What do you need to know to start the question? So what do you think we need to know?
How much money they have.
Yeah. Okay, how much money each started with, I guess? And then what else do we have to? Yeah, how much is each saving? Okay, so here's the information you need. Nadia has saved $16. Her sister has saved $34. Each day that they work, Nadia adds $5 to her savings, while Lucia adds $2. So how would we figure out if they would ever have the same amount? Thus being, huh? Graph it. Okay, so what do I graph? Can we come up with an equation for Nadia? Nadia's amount, let's call it A, is what? Yeah, we start with 16, and then we're adding, how much? 5. So just 16 plus 5? I hear an F. What's 5x? Or each day? Or 5D? Okay, so does everybody see how I got Nadia's equation there? Okay, so then now we have Lucia. Lucia starts with, her amount is 34, and then each day she adds $2. So does everybody see that because Nadia's adding more that eventually they'll be the same, and then somebody will overtake it? Okay, so now my question to you is, do I need a 4-quadrant graph or a 1-quadrant graph or a 2-quadrant, like how? 1, okay, because they're both positive, right? Okay, so if we're going to make this right here, what's this axis going to be called? Huh? So A is what I use there, so that would be the money. Okay, and what's going to be our x-axis? By the way, we should be using a ruler. So this is actually our D, and that stands for days. Okay, so I'm going to get my ruler and do this better. So there we go. And there we go. And then I'll put an arrow and an arrow. Okay, what should we start our scale at? Huh? Okay, well, let's do the days. Should I start my days at 0? And then go up by what? Go up by 1? Go. Well, let's see if I go up by 1s how much I have here. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So there's 20 days worth. I think that should be enough. But I guess if it isn't, then we'll have to redraw it. Okay, so just because I'm going up by 1s doesn't mean I have to label each one. So I'm going to label each second one because it's a little neater that way. Does everybody agree it's a lot neater if I actually label, say, every second one, even though my scale is going up by... And we're using the squares as part of our, the ticks, right? Okay, so what should we do our savings up by? So if we go up by 2, let's see here. Did you count already? How many is there? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 20. Yeah, so you're saying go up by 2s should give you plenty? Okay. I'm going to go up by 2s, but that doesn't mean I'm going to label each one. So what would be a good one to label? You could do every second one. You could do every 10, like, so 2, 4, 6, 8, 10. Do you see? 2, 4, 6, 8, 10, 2, 4, 6, 8, 20. It's just a lot neater that way, hey? 2, 4, 6, 8, 30. 2, 4, 6, 8, 40. 2, 4, 6, 2, 4, 6, 8, 50. Okay, hopefully that's enough. All right, so now, are we good? What? Yes. Okay, so how do we do this? We learned how to graph this in the last unit. How do we graph this now? The y-intercept? Okay, let's do Nadia's. The y-intercept is 16. So 2, 4, there's my y-intercept for Nadia. And then what? The slope is 5. However, you got to watch our scale here, right? 5 doesn't mean 5 ticks. So if I go up 1 tick from here, that's actually going up by 2. Yes? Do you see what I'm saying? You got to watch your scale. So to go up 5, because this is going up by 2s, that would be 2, 4, and then halfway, and then 1 over. Do you see that? It would be right there. And if I do that again, just to get a little bit rougher of a thing, I'll go up 1, and then 2, 4, and then over 1. Do you see? Now I'm going to take my ruler and connect the dots. Ooh, it's very steep, hey? Make sure that you have enough to do this, right? Okay, so this is Nadia's. Okay, so now we're going to do Lucia's. I'm going to do a different color. I'll do red. Lucia's y-intercept is 34, so 2, 4. And her slope is 2. Remember, my y values are going up by 2, so really this is just up 1 over 1, up 1 over 1. Do you see? Oh, I think I saw where they intersect here. Do you see that? So there is Lucia's. And there is where they intersect. So can anybody tell me how long it'll take before they have the same amount? 6 days? I just want to make sure everything's good here. So, yeah, that's 6 days. Yes? 6 days? Okay, so this is why graphing, you have to be very precise, because if you're off at all with your slope of your line, it's not going to intersect in the right spot, though. Do you notice when I graphed mine, I actually did the slope many times to get where it was going. I just didn't use one point. Because if you use one big point and you're off where you put your ruler, then you're totally off, right? So there we go. 6 days they solve, they save the same amount. How much did they save? $46. Do you see how to read it off? Do you see? 2, 4, 6, that's $46. Does everybody see that? And you see going this way, that is the 6 days. Yeah? Okay. So we can use equations to model this situation. recording. We can use equations to model this situation, or a situation. Tickets are sold for the school play. Felix buys 3 adult tickets and 2 student tickets and pays $31. Ellen buys 1 adult ticket and 1 student ticket and pays $12. Let A represent the cost of an adult ticket and S represent the cost of a student ticket. Find 2 equations that would represent this. So, can anybody come up with the equation for Felix? $31. Okay, 31. 31 plus all these? Oh, equals, yeah, because he paid $31 for so many adults and so many students. So, yeah, so 3 adult tickets plus 2 student tickets. Does everybody see, like for instance, if the adult tickets cost $5, and I'm just making this up, I have no idea if it costs $5, I would take 3, because he bought 3 adult tickets, times it by 5. That means I paid, or Felix paid $15 for adult tickets. And then the remainder would be whatever the student tickets are, yes? Okay, let's do Ellen. Ellen paid $12, and that is, yeah, 1 adult if you want, and 1 student. Okay. So it says here that the solution of the system of the equations is A equals 7 and S equals 5, or an adult ticket costs $7 and a student ticket costs $5. How would you verify that this is true? Yeah. Okay, so make sure you realize a verification means you sub into both equations and see what? If it's still true. If they are still true. You did this probably starting when you started doing algebra back in the day, grade 8, especially grade 9. You got a solution. If you wanted to make sure you did it right, you subbed that x in and saw if it was true. Okay, so let's try it. So let's see if Felix is true. So Felix is 3 times $7 plus 2 times S. And what is that supposed to equal? It's supposed to equal 31. So we're going to see if it actually is. So this is 21 plus 10, and that equals 31. So that checks. Do you remember doing this? Verification? Okay, so now we're going to do Ellen. Ellen is 1 adult, so 7 plus 5, does that equal 12? And yes, it does. So that means when we learn how to solve this, we know how to check. Okay, here it says, which pair of values is a solution for this linear system? So the linear system is C equals 2D plus 2, and then C plus 2D equals -6, and they're saying solution A says C is 4 and D is 1, and solution B is C is -2, D is -2. So you need to verify which one actually is the solution. So what would you do here? Plug it in and see if it's true. Okay, do that. Let's check to see if solution A works. Okay, so we're going to sub in 4 and 1. So we're going to first check C equals 2D plus 2. So 4 equals 2 times 1 plus 2. So that looks like it works, yes? Okay, but you have to check both. It's not just one. So now we got to check C plus 2D equals -6. So that is 4 plus 2 times 1 equals -6. Did that work? No. You see how sometimes it works for one but doesn't work for the other? This is key. When you check your answers, you have to check both. Okay, so now we're going to try solution B. So C equals 2D plus 2. We're going to sub in -2 equals 2 times -2 plus 2. Does that work? Does that one work? Yeah. Okay. Now we're going to try C plus 2D equals minus 6, and we're going to sub in minus 2 plus 2 times minus 2. Does that equal minus 6? Yep. So which pair? Therefore, solution B is correct. Okay, any questions how I got that? So this is just a matter of checking, right? Yes, no? All right, moving on. So using a diagram to create a linear system. So we're showing that we're using a diagram to create a linear system to model a situation. So 8 passenger vans and 6 passenger vans carried 110 people. So do you see they're saying each passenger van had 8. I don't know how many 8s there were. And each 6 passenger van carried 6 people, and I don't know how many there are. All I know is there's 15 altogether of each, not of each kind, total. So how could I come up with the situation here? So the first thing you have to do is come up with variables. Do you see how in the last example, they actually told you right here that A represented the cost of the adult ticket and S represented the cost of the student ticket? We need to do that. We can't just throw in a variable and not say what it is. So what is the thing we don't know? The number of vans. Just total? Because I know there's 15 vans, so you have to be a little bit more specific. Of each type. So what would you like to make the variable? We can make E be the 8 passenger vans. Okay, so let E equal the number of 8 passenger vans. And we don't know how many 6 passenger vans is, so what variable would you like for that? S, sure. So S is the number of 6 passenger vans. Okay, so can somebody come up with an equation? We need 2, but can you come up with 1? Okay, so how about this? There were 15 vans in all. What would have to add up to 15? The amount of vans. And what did I have for my variables here? E is the number of 8 passenger vans, and S is the number of 6 passenger vans. Do you see that those two should add up to 15? Yes? So E plus S equals 15. What do you mean multiple things for it? Yeah, we're going to, for all of these, because we have 2 unknowns, we usually have 2 equations. So the second equation has to do with the number of people. So what's going to add up to 110 here? The number of people. How am I going to figure out the number of people that are in the 8 passenger van? I'm not going to take 110 and divide by 8 because there's some that are in the 6 passenger van. So, and don't say I'm dividing by 14 because as you can see, the multiples of 6 and 8 aren't necessarily the same amount, right? Okay, let's try again. What else? Yeah. So does that make sense to you? Very good. That 8 times the number of 8 passenger vans. So for instance, if there was 10 8 passenger vans, that would mean 80 people would be in 8 passenger vans, yes? And 6 times the number of 6 passenger vans. So for instance, again, if I just make this up, if there was 10 6 passenger vans, 6 times 10 means 60 people would be on the 6 passenger vans. And those two should add up to 110 people. Like I said, this is going to be the hardest thing that you're going to have to practice. So make sure you practice tonight coming up with these equations, because we're just going to go at it starting tomorrow with the word problems, right? So now they give you the answer. They said that there was 10 8-passenger vans and 5 6-passenger vans. To verify that that is true. So how do we verify? Yeah, we're going to take that and plug it into those two equations, and it has to work in both for it to work, right? So we're going to check. E plus S equals 15. So 10 plus 5, does that equal 15? Oh, yeah. Oh, yeah. But we can't just say it's all good. We have to check the second one, right? So that is 8E plus 6S equals 110. Whoops. I had to write 110 properly. So 8 times 10 plus 6 times 5, does that equal 110? So 8 times 10 is 80, and 30, that sure adds up to 110, so that is true. Okay, so do you see how you verify? Okay, so I'm gonna give you some time to think on this one here. You don't have the table? Oh. I'm going to white out the table then. Apparently you don't have the table, so, or the solution part. I don't know why mine is different than yours, so that's okay. I'll just white this out. Okay, so it says use a table to create a system to model this situation. A school sold 175 smoothies to raise money for charity. A banana smoothie cost $3 and a peach mango smoothie cost $5. The school raised $625. So I want you to come up with the equation. So they're saying use a table. So what would I put in the table? You saw me erase it already, but what would I put in the table there? So banana and peach mango. We're going to have total where? Total? Here? Okay. Are you sure you want to have, how would you? Okay. Okay, I'm going to give you some time to think about this, okay? Because half the battle, I can tell you all the answers every single time, but you got to have to come up with a way to figure this out, right? But you need to tell me what the variables are. So don't just put B as banana. What does that mean? Is it the cost of the banana smoothies? Is it how many banana smoothies there are? How many? So this is the number of banana smoothies. Okay. Okay, so then P, is that what you're using, is P? P is the number of peach mango smoothies. Yeah? Sold, I guess, right? Okay, so again, this question actually shows you a way to do it with a table. So do you see that if I have a banana here, peach mango, and this is the cost, this is the number of, and this is the total maybe, I don't know. Or maybe the total is the other way around. So the cost is $3 and $5, and what else do we know? Maybe this is the total, and we know that that adds up to $625. And this is B, this is P. Do you see we're getting a total here and we're getting a total here, but we don't have actually some things here. They do give you some information in here that the number of banana and the number of peach should add up to 175 here. Do you see that? So it's up to you if you want to use a table. This is just another method of coming up with the equation. So B plus P equals 175. And what's going to add up to 625? The cost. So how much is the cost of the banana going to be? Well, 3B. It's going to be the cost times the number of bananas sold, right? Do you see? And this would be 3P. And do you see that would add up to the total? So that's how a table kind of helps, because you can see what you're actually getting, like different variations of how you're organizing your information. So then you get 3B plus 5P equals 625. Yes? Okay, so then it says that the school sold 125 banana smoothies and 50 peach smoothies. Use the data in the problem to verify these numbers. So I'm going to give you a second to verify, or did you already verify it? Okay, I'll give you a second to verify it. So what are we going to do? We're going to plug it into both of those equations up there, yes? Did we verify? So B, I'm just going to rewrite this over here. B plus P equals 175, and 3B plus 5P equals 625. So we're going to verify this. So 125 plus 50, does that equal 175? Notice I put a question mark on here because I'm supposed to be verifying it. And then the check mark. And then, of course, students ask me, do I have to put check marks and all this stuff? Well, no, but this shows that you're actually verifying it, okay? And then 3 times 125 plus 5 times 50, does that equal 625? And I don't think I can do that in my head by just looking, so I'm going to write this out. 375 plus 250, does that add up to 625? Yes, it does. There we go. All right.